Part 2, this is for questions 7 to 10. Question 7 is coming from implicit differentiation. The equation of a curve is x cubed plus 3x squared y minus y cubed is equal to 3. And then part 8, they're saying show that dy dx is this. Now, we are going to differentiate everywhere with respect to x. So I'll begin with this x cubed. Then here, this is a product of 2. So I'm going to first keep 3x squared constant. Then I differentiate y with respect to x. Then I'll keep 3y constant. And then I differentiate x squared. You can say you are, keeping y constant and then differentiate the x squared. It is okay. 3x squared. It's very okay. But 3 being a constant, may I put it outside here? Then minus, then we shall also differentiate this y cubed with respect to x. And then this other side is the same. We shall do to this 3. But you know that when you differentiate a constant, you get a 0. Now here, we are using product rule, okay? Also, one thing you need to know is that when you are differentiating a function of y with respect to x, since y is a variable, then we shall differentiate that function first with respect to y. Okay, then after we multiply by dy dx, because this dy will be cancelling with that one, and then you remain with what we are having here. You see that? You don't say that y here is a constant, because for that case, then it will go and you'll have a 0. So when you differentiate here, what do we get? We get 3x squared, then plus here we shall get, of course, 3x squared, but then times when you differentiate y with respect to y, you get a 1, but then you will multiply by dy dx, like I said here. Okay, then plus this will be 3y, then times, when you differentiate x squared, you get 2x, minus this will be 3y squared when you differentiate y cubed with respect to y, but then you have to multiply by dy dx. And then this side, when you differentiate a constant, you will get a 0. Then we are supposed to get these parts here that I've gotten, dy dx, then we put them on one side. So we factorize out the dy dx. But now looking at what is here, y is positive. But when I look here, y is negative. So that means I'm going to take the terms this side. So when I take them this way, I will have y will be squared. Then this one will be minus when it crosses. So it will be minus 3x squared. Then I'll put these ones in brackets. And then I will have dy dx. You see that? Then this way, we shall have this 3x squared. And then we have this one here, which is 6x, then y squared. And then our dy dx is going to be what we are having here. But I'm going to factorize, because I can see that this one is in the simplified form. So 3 being common as a number, I'll put it out, then plus, here we shall have 2x y. Pardon me here, I think I put a square when it is not supposed to be there. So here and also here. So it is supposed to be that. Then we divide by, you come to this one here, also 3 is common. So we shall have y squared, then minus x squared. So you see that this one is going. So that means our dy dx is going to be x squared plus 2xy, then out of y squared minus x squared. And this is exactly what they wanted us to show here. Part B, find the coordinates of the points on the curve where the tangent is parallel to x-axis. I've always done this kind of illustration, so let me repeat it here for you also. Suppose this is the x-axis, and then this is a line that is parallel to x-axis. Okay, this is x, this is y. Now this line here, which is parallel to x-axis, has gotten points here where x's are changing, but the y's are all constants. So we have x maybe 2, and then we have y. Now the gradient of such a line, remember, it is changing y over changing x. So we shall have y minus y out of x2 minus x1. So this one actually gives us what? 0. Okay, so that means for any line that is parallel to x-axis, its gradient is what? 0. So let me write it here actually. So therefore, we have to get the dy dx we have gotten, and then we equate it to 0. So we have x squared then plus 2xy out of y squared minus x squared is equal to 0. Or you can just get the numerator and you equate it to 0. For a line that is parallel to y-axis, you get the denominator, then you equate it to 0. Now when we cross multiply, we shall get x squared then plus 2xy, which is equal to 0. Now x is common, that means here we shall have x then plus 2y when we factorize. That means x can be equal to 0, or you get this one and equate it to 0, then x can be equal to negative 2y. Okay, now let me put this on this side. Now for x is equal to 0, we are going to go to the equation of the curve. Okay, the equation of the curve was given as x cubed then plus 3x squared y and the rest. So we have x cubed plus 3x squared y minus y cubed, I think is equal to 3. Yes. Then we substitute wherever there is x, so we shall put a 0. That means here you have 3 squared y minus y cubed, then is equal to 3. So we get negative y cubed, which is equal to 3. You take the negative and then you get the cube root of negative 3. That means what we are having here, the coordinates of that first point will be x is 0, but then the y is the cube root of negative 3. Or you can take out the negative and then you say negative of cube root of 3. It's all the same. So that is that. Then we also go to this one here. Where there is x, we are going to put minus 2y. So we cube, then plus 3, then minus 2y, then there is a y, then minus y cubed. This one is equal to 3. When we cube negative 2, or the power of a negative is a negative, so that is negative 8y cubed, then minus, this will be 6y, there has to be a square here, so meaning this one is wrong here. When you square the negative, it's a positive, so 4 times 3, that will be 12, then y cubed, then minus y cubed, then this one is equal to 3. So this is 12 minus 9, that one will give us a 3. So you have 3y cubed, which is equal to 3. When you divide all through, then we get y will be equal to the cube root of 1, which is actually what? 1. And then the coordinates of that other point will be, of course, our x here shall be equal to negative 2, then times this 1 here, which will give us negative 2. And then we shall have negative 2 and then 1. And that is that. Question 8, we are seeing partial fractions here. If you are given partial fractions in part A, then part B expected from integration or binomial expansions. Let f of x be this, then part A express f of x in partial fractions. So here we are seeing a linear factor, and then here a non-factorizable quadratic factor. So for that case, we are going to write this, so 3x minus 1, and then x squared plus 3. This one can be the same as a out of 3x minus 1, this being linear, and then we shall have bx plus c, because this one is a non-factorizable denominator, I mean quadratic factor. So out of x squared plus c, I mean 3. But then before you do this, before you express this in partial fractions, you have to first look at the degree of the numerator and that of the denominator. So when I get 3x then times the x squared, that one will give me 3x cubed. Okay, so the highest power of x is what we call the degree of the polynomial. It is 3 here, but then here it is 2. So if the degree of the numerator is less than the degree of the denominator, then it's okay, you can now go ahead and express in partial fractions. But then if you find that the degree of the numerator is greater or equal to that of the denominator, then that is what we call an improper fraction. So you have to first long divide. Okay, but for this case we just go ahead. So of course we shall multiply these two here to get the common denominator, then multiply this with that, and then this with that. So when we do so, we shall have a times the x squared plus 3, then plus bx, then plus c times the 3x minus 1. Then we shall equate this one to x squared plus 9xy, because this one is going to be under this when we multiply these two here. Okay, but also this one here is the denominator. It has the same denominator. So if the denominators are equal, they cancel out, and then these will be the numerators. So that's why what we get, we just equate it to the numerator that we are seeing here. Okay, all right, then the next thing we do, we are supposed to find the values of a, b, and c. Okay, so how do we do that? We can get values of x that can terminate some of the terms here, and then we get those that are remaining. For example, if let's say x is equal to, from here I can equate this one to 0. When I equate it to 0, x will be a third. So if x is equal to a third, that means I'll be terminating the whole of this, then I will be remaining with this. Now you get a third, you square it, then plus 3, that will be 1 over 9, then plus 3. So 9 times 3, that is 27, then plus 1, that will be 28. So I'll have 28 out of 9 of a. Then this one will be equal to, we go to this side, when you square, that will be 1 over 9, then plus 9 times a third, that one will be 3. So this times this is also, I think it is the same as the other, 27, then plus 1, that is 28 out of 9. So we shall have 28 out of 9. That means our a shall be equal to 1. That one we are done. Then of course you cannot get a 0 here, that you equate this one to 0, you'll get complex numbers. Okay, so we can look out for other x values. Suppose x is equal to 0, because I can see the x is here on b. Now that means this one disappears. We shall get 3 of a, then plus this one goes, then there is a negative 1, then times the c. So we shall have minus c, which is equal to, of course this side we shall get a 0. So what does this mean? 3a is equal to C. But A is 1. That means our C is what? Is a 3. And that is that. Then, since the values of x are done, which can terminate some of the terms here, then I can get any other value. So for example, if x is equal to 1, then we substitute here. 1 squared is 1 plus 3. That will give us 4 of A. Then plus, put here 1, you will get a 2. Okay? So 2 times this. So you'll have 2b, then plus 2c. Then this one will be equal to, I think here you get a 10. 1 then plus the 9. Not so? So we got A and C. We shall have a 4 here times 1, then plus 2b, and then plus 2 times C, which is 3. Then this one is equal to 10. So how do we get B? We shall get a 10, then minus the 6 we are seeing here. In fact, this is 4 plus 6. That is 10. And divide by 2. Automatically, B becomes what? 0. So what does this mean? Our f of x is now going to be a out of 3x minus 1. And our a is a 1. So we shall have 1 out of 3x minus 1. Then plus b x. But that one, b is 0. So we were supposed to have something here of x, then plus now the c. But since that one is 0, the x disappears. Then we shall have a 3, then out of x squared plus 3. And that is that. Now part B, you can see that it is coming from integration. Hence find the integral of f of x from 1 to 3 with respect to x. Now, what are we going to have here? When we are integrating from 1 to 3 of f of x with respect to x, this one will be, we are integrating from again 1 to 3, and we have 1 out of 3x minus 1 with respect to x. Then, in fact, I can say this plus 3 out of, this is 3 plus x squared, like that. Now we can have the integral of, we integrate these individually. So 1 to 3, then we have 1 out of 3x minus 1 with respect to x, then plus, I can take that 3 out, then 1 to 3, then this is 1 out of, we have, I can write this one as root of 3 squared, then plus x squared with respect to x. Now, we know that when you integrate 1 out of a squared plus x squared with respect to x, we always get 1 out of a, then the arctan of x out of a, if you check in the list of formulae. Now, that is why I had to write this 3 as the square root of 3, then I square, okay? Because this square can cancel with this, and then you come back to this. You see that? All right. Now, that means our a is this root of what? 3. Now, that one is done. Then here, since I'm seeing a constant and I can differentiate this, when you differentiate this, you are getting a 3. Not so? And we know that if you integrate and you see that the numerator is the exact derivative of the denominator, then what you get is the natural log of the denominator, okay? But when we differentiate the denominator here, we are getting a 3, okay? But if you get that 3 there, if you differentiate the 3x minus 1, we are getting a 3. But here we are seeing a 1. So how do you convert this 3 to a 1? You multiply it by a third. So this operation you have done on your derivative is what you are going to write as the multiple of the natural log of your denominator. You see that? Or in other words, what I'm going to write is this one here. You are integrating from 1 to 3, okay? Then up here, you are going to get a third times the the derivative with respect to x of that 3x minus 1. Remember here I'm supposed to have a 1, okay? So when I differentiate this with respect to x, I'm getting a 3. Now when I multiply it by a third, I'll get this one here. You see that? So that one there. Then here we shall have plus 3. And then, of course, here we shall have times 1 out of our a is square root of 3, not so? Then arctan of, this is x out of the a, which is the square root of 3. Then I can put a constant. Okay, then this other side, when I take this one here, I'll be having the derivative of the denominator up there. So using this one here, then we can have a third, which is out, then the natural log of the denominator. You see that? Then plus, this will be 3 out of root of 3, then the arctan of x out of the square root of 3, then plus c. So that is that. That's our integral from 1 to 3 f of x dx. Okay, now of course we have the limits. So if we have the limits, then we don't need to put the plus c. Okay, when we put those limits, the c disappears. So I'm going to just put something like this. And remember not to bring back the integral sign when you do it. When you begin the process of integration. Okay. All right. Now here, putting the upper limit, we shall get a third. Then the natural log of 3 times 3, that is 9 minus 1, that will be 8. Then plus 3 out of square root of 3. And then the arctan of 3 out of root of 3. Then we go to the lower limit, so put 1. We shall get a third. Then the natural log of 3 minus 2. 3 minus 1, you get a 2. And then plus, this will be 3 out of the square root of 3. And then the arctan of x out of, but x is 1, out of the square root of 3, like that. Then here we are going to have, I can even take this one up here, or I can leave it as a third, then natural log of 8 minus the natural log of 2. Okay, because I can see a third here and then a third here, so I can factorize it. Then next we have this one here, plus 3 out of root of 3. Then arctan of this, this one is the same, 3 out of root of 3, so times root 3 times root 3. Now this one becomes a 3 and it cancels with that. So that means inside here we have root of 3. Arctan of root of 3 gives us 60 degrees. But 60 degrees, you're not going to write what? 60 degrees, but you will write pi over 3. You write it in radians, okay? So that is pi over 3. And then minus, arctan of this is 30 degrees, okay? So I'm putting a minus here because there is this minus which affects this, okay? And I factorized out this 3 out of root of 3 with this one out here. All right. Then here we are going to get pi out of 6. Now 60 minus 30, don't you get 30? All right. So here we are going to get a third, then the natural log of 8 out of 2, using the rules of logarithms. Okay, then here I can simplify this and I say times root 3 times root 3. Then inside here, since we don't write square root the square root decides in the denominator. Even when you put this one in the calculator, it will give you the simplified version. So this one gives us pi over 6 here. So meaning we shall get a third, then the natural log of 4, and then plus this one will be root of 3, then times pi out of 6. Or I can write this one last, just like that, and this becomes our final answer there. Or I can even take this further. I can write this one as 2 squared. Okay, I'll have a 3 here, so this is 2 squared, then plus pi over 6 of root of 3, then drop this one here, then we can get 2. So this one can be 2 out of 3, then the natural log of 2 plus pi out of 6 of root of 3, and that is that. Question 9 is coming from vectors. The lines L and M have vector equations, these ones here respectively, where A and B are constants. Given that L and M intersect, show that B minus A is equal to 4. So what we have to do here is to solve these two simultaneously. So we have the parametric equations. For this one here, we are going to have -1 plus 2 lambda, then the y coordinate is 3 minus lambda, then the z coordinate is going to be 4 minus lambda. Then R2, for this other one here, it is going to be 5 plus a mu, then 4 plus b mu, and then the other one is 3 plus mu. You see that? Then for the intersection of two lines, they are going to be having the same x coordinate, y and z. Okay, so for intersection of the lines, of the two lines, then we can have -1, the x coordinate here shall be equal to the x coordinate of the other. The y coordinate shall also be equal to the y coordinate as the z2. So 3 plus mu. And then from there, we solve them simultaneously. So right from, now why did I write z? This one has to be lambda. Okay, that one has to be lambda. Now, right from here, I can actually eliminate lambda. Not so? I can eliminate lambda, or I can express this lambda, I mean this mu, in terms of lambda. So I substitute it in equation 2, okay, and then also substitute in equation 1. I think that one is better. So let me say this is equation 3, this is equation 2, and this is equation 1. So I can say from equation 3, this mu shall be equal to, bring this one here, so it will be 4 minus 1, that is a 1. I mean 4 minus 3, that is a 1, then minus the lambda. Then we can substitute into equation 2. So we have 3 minus lambda, then minus, this is 4, I think this is equal to 4, then plus b, and then mu is 1 minus lambda, not so? So we can make b the subject of the formula or lambda the subject of the formula. So you have 3 minus lambda, then is equal to 4 plus b minus b lambda. Then I can bring this on this side. In fact, I'm going to make lambda the subject of the formula because we are looking for b and a. Okay, so let's make lambda the subject of the formula. Bring this on this side. We shall have b lambda, because it is a negative, it becomes a positive. Then minus the lambda here. Then we have 4 plus b minus 3. So lambda here is common, so we shall have b minus 1. Then here we shall have b. 4 minus 3 is a 1, so we shall have b plus 1. So meaning lambda shall be equal to b plus 1 out of b minus 1. You see that? Then after getting the value of lambda, okay, we can now get the value of this mu here. Okay, so that means our mu, okay, shall be equal to 1, then minus the lambda is b plus 1 out of b minus 1. Of course, this one is over 1, so get this times that, you will get b minus 1, then minus this one will affect everything here. Okay, so b minus, then minus 1, then out of b minus 1. Or maybe I can write that, okay, so that you can follow properly. So b minus 1, then minus b minus 1 out of b minus 1. Now our mu is going to be, b disappears, and then we get, what does this one give us? We are going to get minus 2 up here, then out of b minus 1. Those are the two values of lambda and b. I mean lambda and then mu. Then we can now substitute in equation 1. So substituting into equation 1. So we have negative 1, then plus 2 lambda. Lambda is b plus 1 out of b minus 1, not so? Then we are equating this to 5, then plus a, and then our mu is negative 2 out of b minus 1. Then we open the bracket, so you can see that we have eliminated the lambda and the mu, so we shall have b and a. Now here we get the LCM, so this is over 1 and this is over 1, so we shall get this times this one here. You will get minus of b minus 1, then plus 2 of b plus 1, then this one is out of b minus 1 when you get 1 times this to get the common denominator, not so? Then also here, this one here times the 5, so we shall get 5 times b minus 1, then plus a times the negative 2, then out of b minus 1. Now you can see that the denominator is the same, so they will cancel out, okay? And then we equate the numerators. So here when we open the brackets, we will have minus b, then plus 1, then plus 2b plus 2, then this one will be 5b minus 5, then plus, I think it's a minus 2a, okay? So we put everything onto one side, okay? What did they tell us to find? So this is, the constant is on the right side. All right, so we are going to have here 2b minus b is another b, then plus a 3. Now bring this on this side. That one will be minus 2a. Then when I bring this one this side, it will be a minus 5b, not so? Then this one will be equal to, we have a minus 5 here. This is minus 5, but then, yeah, I think that is that. So we take this 3, this other side, So b minus 5b, that is negative 4b minus 2a, which is going to be negative 5. When this one crosses, it's a minus, so minus 3. Now, of course, negative 2 is common, so I can take it out here. Then we shall have 2b plus a. And by the way, this one is a negative. When it crosses, it has to be a positive. Pardon me here. So this is a positive, this is a positive. So when I pull out the negative, because I want to make b positive, as you can see here, is positive. Then what else? So when we go to this side, this will be negative 8. So when I pull out the 2, then this one will be a 4. Not so? So this one will go. And then we shall have our answer as 2b minus a shall be equal to 4. And that's exactly what they have told us to show, isn't it? 2b minus a is equal to 4. Part B, given also that L and M are perpendicular, find the values of A and B. If these two vectors are, these two lines are perpendicular, that means their directional vectors are the ones that are perpendicular. So we get the dot product or the scalar product of their directional vectors, and then this one has to be equal to 0. So when we check back here, the scalar product of L is this one here, which is 2 minus 1 minus k. 2 minus 1 minus 1, and then AB 1. Okay, so we shall have 2 minus 1 minus 1, then dot it with A, B, then 1. This one should be equal to 0. Then from here we shall have 2A minus B minus 1, which shall be equal to 0. Okay, what does this mean? We can have 2A minus B, or I can say 2A then minus 1 shall be equal to B. Okay, now we are going to solve these two. Solving this 2A minus 1, which is equal to B, and the other equation we got is 2B minus A, which is equal to 4. So we solve these two simultaneously. Okay, simultaneously. Now, what are we going to have here? We are going to substitute B here, not so? So we are going to have 2A minus 1, that is the value of B, but there is a 2 here, then minus A, this one will be equal to 4. Then you open the brackets, that will be 4A minus 2 minus A, this is equal to 4. 4A minus A, that one will give us 3A. When this one goes here, it adds to the 4, then we get a 6. So that means our A is going to be equal to 2 if you divide all through by 3, not so? Therefore, what will be the B? B will be, I'm substituting maybe in this one or this, you use whichever you want. So it will be 2 times 2 minus 1. If I use this one here, 2 times 2, that is a 4. Then 4 minus 1, that one gives us a 3. So B is 3 and then A is 2. Then part C, they are saying that when A and B have these values, find a position vector of the point of intersection of L and M. Now, we need to find the value of lambda that we got before. So value of lambda, the expression is B plus 1 out of B minus 1. You remember here? So we are going to have B plus 1 out of B minus 1. So our B is a 3 plus 1, that will be a 4. Then 3 minus 1, that will be a 2. So 4 over 2, that one will give us a 2, not so? Then we also need to find this mu here. Or you can use one of them. If you want, you can find the mu or the lambda, but I can leave that one there. So since these two intersect, that means they have the same x coordinate and the same y coordinate. So I can substitute in here. This one is going to be the point of intersection, or this one here. Okay, So suppose I take this one here, we are going then to have 1 plus, so I can let this one be the point of intersection to be P. So this one is going to be 1, then it is -1 plus 2 lambda. Then we also have 3 minus lambda, then 4 minus lambda. Now, when we substitute the value of lambda that we have gotten here, this is -1, then plus 2 times 2, then 3 minus 2, and then 4 minus 2. Then, what do we get here? Our OP is therefore going to be 4 minus 1, don't you get a 3? So you get 3, then this is 1, and then this is 2. So we have 1, let me first remove this, 1, and then 2. And that is that. Or you can write it in terms of I, j, and k. So it will be 3i, then plus j, then plus what? 2k. Okay. You could also maybe get the value of mu here. Okay, then you substitute here. So that means you will need the value of A you have gotten and the value of B, then also this other one here. But I didn't have to use this one because already this one I was just substituting one value. Okay, so that is that. Question 10 is coming from complex numbers. The complex number -1 plus root of 7i is denoted by u. It is given that u is a root of this equation here, where k is a real constant. Find the value of k. Now, if u is the root of this one here, this means that its complex conjugate is also a root of this, okay? Because these complex numbers move in pairs. They move in conjugate pairs. So I'm saying that if u, which is equal to -1, then plus root of 7i, is a root of the polynomial 2x cubed plus 3x squared plus 14x plus k, okay, which is equal to 0, then also its complex conjugate, how do we get the conjugate? We just change the sign of the imaginary part. This one here is also a root, okay? Now we need to get, now we are having two roots, so meaning we can now get the quadratic factor that comes out of these two roots, okay? All right, now how do we get that? If you are finding the quadratic equation from the roots, you know it is given by x squared minus then the sum of roots times x then plus the product of roots is equal to 0. So we need to get the sum and then the product. But how does that come about? Suppose I have two roots and then I have x is equal to a, then the other one is x is equal to b. Now give us the factors from which these roots come. So I will have x minus a, okay? Then the other one is x minus what? B. So you have something like that. Then when you open the brackets, you have x squared, then this times that, you get minus bx. Then these two multiplied, you get minus ax. And then these two multiplied, we get a positive ab. Now I can say x squared minus, when I pull out the minus x inside here, I'll have a plus b, okay? Like that. So you can see that this is the sum of roots, not so, and then this is the product of roots. So long as I know the sum of the roots and the product of the roots, I can always get the quadratic equation. So we need to get the sum of these two, then also the product, and then we get the quadratic factor from there, okay? All right. Or you could do this this way, and then you say we have our x, which is equal to -1 plus root of 7i, not so? You also have another x, which is equal to -1 minus root of 7 what? I. Then you get a factor. Here, you get x. When this one comes this side, you have minus, I think this one will be a plus, then minus root of 7i, not so? Then also bring this one this side, you will get x, then plus 1, then plus root of 7 what? I. Then this one will be equal to what? To 0. Now we open the brackets. So x times whatever is here, that one will give us x squared, then plus, but I'm not going to waste time, okay? I'm just going to do the other one. And then I say that we are going to have x here, then minus the sum of roots, like I've shown you before, sum of roots times x, then plus the product of roots. Then this one is equal to what? 0. So we shall have x squared minus the sum of the roots. So I have -1 plus root of 7i. Then we shall add -1 minus root of 7 what? I. Then times x, then plus the product. We have -1 plus root of 7i. Then -1 minus root of 7 what? I. That one is equal to 0. So of course, in here, you're going to see that this I disappears, then you get a -2 of x, and then plus here. This one is the difference of two squares, not so? So we are going to have 1, okay? Okay, let us write -1 squared, then minus, this is root of 7i, then we square that. Now this one will give us x squared, then plus 2x, then plus. Okay, what do we get here? So this is a positive one, and you should know that in complex numbers, I squared is always equal to -1. So when you square here, that one will give you a 7, then times a -1, and then here there is a negative, so it becomes a positive. So you have a 7, then plus a 1 that is here, then this one gives you 8. And so, so we shall have plus 8, which is equal to 0. Now, we can do long division from here. Let me extend this one a little bit here so that I can create some space. Like that. Now, what are we going to have? We are going to use long division here, okay, to get this other value here. So if this one is a factor, okay, and this one is a factor, then that means their product, the quadratic factor that is coming from 2 is also a factor, okay? Now that means the remainder has to be what? 0. So I'm going to use long division here. When I use the long division, then it will help me to get the remainder. Then I get that remainder and I equate it to 0. Okay. There are two methods actually you can use here. I can show all of them. Now, the first one is this. I will get this x squared, then plus 2x plus 8. I divide it in this one here. So something like that. Don't know whether this one is too wide. So when we divide here, what do we get? You divide the first with the first, the rest you multiply. So 2x cubed divided by x squared, you will get 2x. So you write it up here. Then this times that, you will of course get 2x cubed. And then this times that, you will get 4x squared. And then 8 times the 2, you will get 16 of x. And then when you subtract, Of course, the first one goes, and then 3 minus 4, you'll get a negative 1. Then 4 minus 16, isn't that, I think it is 14, yes, 14 minus 16, that's a negative 2. So we shall have minus 2 of x, and of course k will come down here. Then negative x squared divided by x squared, you'll get a negative 1. Then the rest you multiply by that negative 1. So we shall get negative x squared minus 2x minus 8. Then when we subtract, this one disappears, this one disappears, then we have k minus minus 8. So that means the remainder here is k plus 8, okay? So like I said, since this one is a factor, okay, then the remainder has to be 0. So we shall get this k plus 8, then we equate it to 0, and then our k is going to be negative 8. And that is that. Alternatively, from here, okay, we would say that this 2x cubed, then plus 3x squared, plus 14x plus k is the same as having this quadratic factor here, x squared plus 2x, then plus 8, then times a linear factor here. Because this one is a using the factor remainder theorem, because this one is a factor, that means the remainder is 0. So we shall not have a remainder we are adding here, because remember, the polynomial is equal to the divisor times the quotient, then plus the what? The remainder, okay? All right, now, what are we going to have here? It is simple. We are multiplying by something here, but since this one is 2x cubed, and we are having x squared here, that means here I must have 2x. Is that clear? So when you get 2x, then times the x squared will give you this one here. Then I don't know any other, so this one is a monomial here. That means I can add an a here, okay? And then we say, of course, we are adding a 0. Then we open the brackets here. So when we open the brackets on the right side here, this times that, you will get 2x cubed, then plus, again, times that, so you will have a x squared, this times this, that is 4 x squared, then this times that, that is 2ax, then plus 8 times this, that is 16x. Then what else? We have HA. Now, this one means that I'm going to take this one down here. We simplify this. So we are going to have 2x cubed, then plus. Now, the ones that have gotten square, x squared, so we have a, then plus the 4. So I would say a plus the 4, then x squared, and then plus the ones that have gotten the x, we have 2a, then plus the 16 of x, and then plus this is 8k. Now, from here, we equate the two values, okay? We equate coefficients or the terms in here. Now, you can see that this is 2x cubed, this is 2x cubed, okay? When you go to the next one, this is 3. The coefficient of x squared here is 3. The coefficient of x squared here is a plus 4. That means from there, we can get the value of x. So that means you can have a, then plus, 3, then this one will be equal to a plus the 4. So from here, that means a is equal to what? 3 minus 4, which is a negative what? 1. Are we there? Then, do you see that if I put negative 1 here, it is the same we got up here. It is 2x minus 1. All right, now how do we get the value of k? So we can see k here as the constant term. Then the constant term is here. So that means k shall be equal to 8 times negative 1. Isn't that giving us negative 8 as what we got here? So that is that you can use this method here. This method is beginning from here. After getting this, then you proceed like this, or you use the quadratic formula, the long division. Okay, so let me actually put here alternatively, you can do it this way, and that is that. Then part B, find the other two roots of the equation. Of course, the other root is the complex conjugate, not so? Now, since we have long divided here, we have actually simplified the work that we are going to do here. So 2x cubed, then plus 3x squared plus the 14 of x minus 8 is the same as we have x squared plus 2x plus 8, then times in here we are having 2x minus 1. You see that? Then after that, we can get this one here. Remember, this equation here is equal to 0. So we can have that. That means if I get this 2x minus 1 and then I equate to 0, our x here is going to be equal to a half. Okay, so the other two roots, we are having this one, and then the other, we have this x squared plus 2x plus 8. When you equate this one to 0, already we know that 1 is going to be negative 1 plus root of 7i, and then the other one is going to be negative 1 minus root of 7 of I. So we have the other two roots are this one and then this one, where this one is the complex conjugate of the complex number which we were given. Is that clear? Okay, so now based on how this equation, how this question was set, here we were having only 3 marks. So that means you could take this method, you get the quadratic factor that is coming out of these two, then you go like this, and then you get this value. Then you can use now the long division. You don't even need to do that because already you have gotten the value of A. So it's the same thing. It's all that. So because we have done all the donkey work in part A, then part B becomes very easy. So all the marks, some marks that would have gone in here, they will give them to you this other side. So that is that. Part C, on an Argand diagram, sketch the locus of points representing the complex number z satisfying this equation here. Now here, whenever we have the modular signs on one side of the equation or inequality, then this one is a circle, okay, whose center is going to be this u here, and then this would be the radius. Okay, so suppose we have our z. Let me prove this to you. Suppose we have z, which is x plus iy, then our u is, let's say, a plus bi. It's a complex number. Now in here we shall have x plus iy, not so, then minus. So the minus will affect everything here for you. So minus a minus bi. Okay, so I'm going to separate the real part from the imaginary part. So this will be x minus a, and then here we shall have y minus b of I. Then how do we get the modulus of a complex number? We get the square root of the real part squared, then plus the imaginary part squared, not so? Then we equate this to 2. Now square both sides to eliminate the square root. Then you will have this x minus a squared, then plus y minus b squared, which is equal to 2 squared. But then you know that the general equation of a straight line is x minus a squared, the general equation of a circle, not a straight line, then plus y minus b squared, which is equal to r what? Squared. So this one, the center is AB, and then the radius is what? R. So do you see that the center, this one is giving us, it is giving us the equation of the circle right from here. So whenever you see the modular signs on one side of the inequality or equation, you just know that we are dealing with a circle. Is that clear? All right. Now, this therefore implies that what we are having here, z minus our mu I mean our u is -1 plus root of 7I. So it is like that, which is equal to 2. So this is a circle of radius 2 and center. I can say -1, then root of 7, or you can say -1 plus root of 7I. Now I'm going to put my axes here, and then after putting the axes, so it's better, so since this one is a circle, to avoid drawing something that is not perfectly a circle, you use the protractor, okay? I mean, you use your compass to do that. So I can bring my ruler here, and then when I bring the ruler here, you can measure. You can put it here, and then you mark these points properly, okay? You mark them well, such that when you stretch your compass on the ruler, you can easily see the radius as a 2, and then you draw something that is very neat. So after marking these points on the real axis, then I also turn it here, and then I do the same, okay? So after that, make sure that you label your axes. This is the imaginary axis, and then this is the real axis, okay? Now, what are we having? We are given a mark for plotting the center. The center is -1 root of 7. What is root of 7? It has to be 2 point something. So it has to be around there. So I'll bring my ruler, and then I put it there for the purposes of just being accurate a little bit, okay? And then the center is -1, so I'll put it at -1. When we put it at -1 here, do that, then we move root of 7 up here. So let's get the calc, and then we see that root of 7, this one is 2.6, and the rest of those figures. So 2.6 is, of course, beyond the what? The mid value. 2.6, maybe around there. So I'm going to mark this one here, maybe as root of what? As root of 7. So like that. Then that means that our center shall be there, like that. Then you get your compass, you measure 2 units, you stretch your compass on the ruler, and then you measure 2 units, okay? But my compass here cannot go up to 2 centimeters, so I can put it at 4. That one is 4.0. Then I put it here, and then I will draw this. So after drawing that, then I'm supposed to make these ones as tangents, okay? In fact, let me draw these tangents here. I'm going to diminish this, okay? So that the radius is what? Is 2. So here we are having the radius is 2, so 1, 2. That means this one has to be a tangent. Then we also move this way, 1, 2. So this x is equal to 1 also has to be a tangent. But of course, here to move 2 units, it might be hard for you to locate that. But it has to also be 2 units this side. So if this is, this one was 2.6, whatever, then plus 2 units, that will be 4 point something. So it has to be around there. And also this other side, 2.6 minus 2, won't it be 0.6? So around here, okay? So what I'm going to do is to draw these tangents to guide me. So this tangent here, and also this one here, 2 units is there, and then another tangent is going to be around here, 4 point something, 4.6 something, okay? Then also this other one down here 0.6 something. So that means when I'm drawing that circle, it has to touch up here, then here, then here, and then here. Now you see that when you draw using the freehand, it's not going to be so perfect, okay? But anyway, it is a sketch. They can still give you your marks, but better you use the what? You use your compass. Now I'm going to diminish this one, and then it fits into those what? Tangents there. Okay. So that is what we are going to have there. Now I can diminish a little. So we are going to have something like that. I'll take off these tangents. They are not needed. Okay. So that is going to be our diagram. We are not going to shade anything. Actually, we have shaded the circumference of the circle because they need those points that are exactly 2 units from the center. And those are the points on the circumference. Okay. So that is that. I'll need to take away this. And that is that. Then next, determine the greatest value of the argument of z for points on this locus, giving your answer in radians. Now, radians, I mean, this is argument of z. So we are supposed to draw lines from the center here to this circle. So you keep on drawing, you draw. They are saying greatest. Okay, greatest argument. Argument is about the angle a complex number makes with the positive real axis. So when I also connect to this one here, which one is the greatest? So this one has to be the least. Okay. As you keep on coming like this, like that, like that, like that, these ones will be increasing in the angle. The angle will be increasing. So this one here will be the greatest. You see that? All right. So what I will do is to take that, and then this will be my greatest argument. So I need to find a value of this theta here. But then we can maybe connect this one to this one being the center. And of course, the radius is 2 units. Okay. You know that the tangent and the radius in circle properties, these two are always perpendicular, not so? Then from there, what else do we need? I think I will also connect this one here. Now I need to make these lines dotted such that they don't interfere with our diagram that we drew. Okay, and what else? Of course, we have this one here. So this one is, of course, 90 degrees here. So we can look at this triangle here. Already from here to here is 1 unit, not so? So this is 1 unit, and then this is root of 7 here. So using Pythagoras theorem, because this is a right angle triangle, we can find this length here. Are we there? When we find that length there, that means we can find this angle here. In fact, I can say this angle here is alpha. Then I can make this other angle here to be beta. So using this triangle, I can get this angle beta. Then using this triangle, I can get this angle alpha. So I'll get alpha plus beta, then plus the 90 degrees that is here. Then we shall be in position to get that angle there. You see that? So let me use this triangle here. There is this smaller triangle here that is coming like this, and then also, so here we have 1 unit. So this is I've let this one to be beta, then this is root of 7. So relative to this angle here, this is the opposite, and then this is the adjacent. So that means tan of beta shall be equal to the opposite over the adjacent. So meaning beta will be equal to the arctan of 1 out of root over 7. I can keep that one there. Then we also proceed. We have this other triangle here. Let me also draw it like the way it is to make the point go home. Then I have this one here, and then that one there. So the triangle I'm talking about is this one that is dotted like that. So this is 90, this is 2 units. Then we don't know this length, neither do we know this length here, but we can get this length here using Pythagoras theorem, not so? So this one is going to be the square root of this one squared plus this one squared. That squared plus the root of 7 what? Squared. So this one is giving us 8 plus 1, 7 plus 1 is 8, so root of 8. That means here I have root of 8. Then I find this alpha here. Now, relative to this angle, this is the opposite, this is hypotenuse, so I can use sine. So sine of alpha shall be equal to this 2 out of root of 8. So meaning alpha shall be equal to the arcsine of 2 out of root of what? 8. Then after that, our argument. So the greatest, let me just write the statement, greatest argument of z is going to be equal to this alpha we have gotten plus beta, then plus 90, which is pi over 2. Remember this? And that is our theta. So I had said, I had labeled it as theta. So greatest argument of z theta is equal to that. Now, what is alpha? Alpha is this one here, the arcsine of 2 out of root of 8. What is beta? Beta is the arctan of 1 over root of 7. And then plus this pi out of what? 2. So your calculator here should be in radians because they say that we give the answer in radians. So I will say calculator has to be in radians. Now, when we put this in the calculator, the answer to 3 significant figures, what is it going to be? My calculator is already in radians, so arcsine of 1 out of, no, it's not a 1, it's a 2 out of the square root of 8, then plus the arctan of 1 out of the square root of 7, then we close this, we add pi out of 2. This one will give us 2.72. 2.72. This answer is in radians, and it is to 3 significant figures, and that is that.